Welcome to Caracomp Insider, where high-tech facial recognition meets real-world intelligence.
The next time you walk through an airport gate, a camera will scan your face, check it against a database, and decide whether to let you board. The whole thing takes under 3 seconds. But buried inside those 3 seconds are 5 separate steps, and every single one of them can fail. That should matter to you whether you're an investigator evaluating biometric evidence or a parent dragging luggage through Orlando International. If you've ever walked past one of those cameras at a boarding gate, this system has already made a decision about you. And if that feels a little unsettling, I get it. A machine just looked at your face and rendered a verdict in less time than it takes to sneeze. Most of us assume it works like our own brains. Camera sees face, face matches passport, done. It doesn't work that way at all. So what's actually happening in those 3 seconds? The first challenge is just getting a usable picture. You're not standing still in a photo booth. You're shuffling forward in a line, maybe looking down at your phone, maybe turning to talk to your kid. A passport photo is taken under controlled lighting with a uniform background. A gate camera doesn't get that luxury. It has to work with whatever image it grabs, and that image is almost always degraded compared to what a passport office would accept. The system runs an image quality check right there, evaluating focus, lighting, and whether your face is positioned well enough to be useful. If the image falls short, the math downstream gets harder. And that matters for everyone, because a blurry capture doesn't just slow things down, it's where misidentifications start. Now, why do people assume this is instant? Because our own brains recognize faces in about 200 milliseconds. We see someone and just know who they are. So we figure computers do the same thing, only faster. They don't. A computer doesn't see a face the way you do. It converts your face into a string of numbers, a mathematical template using something called Euclidean distance analysis. That means it's measuring the spatial relationships between your features and turning them into a numerical vector. If the captured image is poor, that conversion fails. And if the conversion fails, nothing after it matters. But before the system even builds that template, it has to answer a more basic question. Is it looking at a real person? This step is called liveness detection. Its whole job is to make sure someone isn't holding up a printed photo or playing a video on a tablet to fool the camera. According to Oculus, passive liveness systems check for natural light reflections on skin, depth cues, skin texture, even subtle micro-expressions, and they do it in under 300 milliseconds. That's about 5 times faster than many competing approaches. You never even notice it happening. Without that step, a simple presentation attack, someone holding a high-res photo up to the lens, could fool a standard face recognition engine into returning a match. So now the system has a usable image of a verified living person, and it's built a numerical template from that face. The next step is comparing that template against a database. The result isn't a yes or no. It's a confidence score, a number between 0 and 1 that represents probability. According to Microsoft Azure's documentation, a high score means it's more likely the 2 images show the same person. A score of 0.95 means 95% confidence. That sounds solid, until you consider scale. According to CBP data, the U.S. Biometric Exit Program has screened roughly 697 million travelers. At that volume, even a 99.9% accuracy rate generates thousands of false matches that a human screener has to review one by one. And that brings us to the step most people never think about, the threshold decision. Every airport system has a confidence cutoff. If your match score lands above that line, you walk through. If it lands below, you get pulled aside for secondary screening. Lower the cutoff, and more people breeze through quickly. Raise it, and you catch more fraud, but you also flag more legitimate passengers. That's not a software glitch. That's a policy choice. Different airports set different thresholds, depending on whether they're prioritizing speed or security. For an analyst reviewing biometric screening data, that threshold explains why two airports using the same vendor can produce wildly different false positive rates. For the rest of us, it means the system that waved you through in San Diego might flag you in London, not because your face changed, but because the airport's tolerance for risk did. The numbers make this concrete. Out of those 697 million travelers screened, CBP intercepted over 2,225 individuals attempting to use fraudulent documents. That's a fraud catch rate of about 0.3%. The system works. But to catch those 2,000 people without grinding every airport to a halt, the false positive rate has to be vanishingly small. Otherwise, you'd be pulling aside 50,000 innocent travelers for every fraudster you stop. The algorithm was never the hard part. Algorithms are fast. The hard part is the judgment call, deciding how confident is confident enough. That's not a math problem. That's a human decision wearing a technical disguise. So remember 3 things. A 3-second face scan actually runs through 5 separate steps: capture, liveness check, template creation, database matching, and a confidence threshold. Every one of those steps can break the chain. And the final call, whether to let you through or flag you, isn't made by the algorithm. It's made by the people who decided where to set the bar. Whether you're reviewing biometric evidence or just boarding a flight home, that invisible threshold is shaping your experience right now. The written version goes deeper, links below.
Now you know something most people in this industry don't. Use it. And when you're ready to put it to work, Caracomp.com. We'll see you tomorrow.